Thanks everyone for coming back after the break. I know it's really nice outside by the water. So I'm really excited to announce our next speaker, Phoenix Perry, who's a lecturer in physical computing and games. And she teaches and does research at Goldsmiths at the University of London. Her work focuses on human-computer interaction, motion, sound, the body, machine learning, and games. Her work looks for opportunities to bring people together to raise awareness of our collective interconnectivity. She's an advocate for women in game development, and she founded the Code Liberation Foundation, which is an organization that teaches women to program games for free. Since starting it in 2012, the project has reached over 2,000 women in the New York area from the ages of 16 to 60, and maybe it's more. Maybe it's even more now, depending on when this was written. And now she's in London, it's true. So I'd like to welcome Phoenix up to the stage. Thank you.
Hey everybody, it's me. Can I hold this thing? Okay. I'm going to talk a little bit about alternative controller games and how I think about games, but I'm also going to talk about, because you guys are probably all hackers and makers and you try and build things in physical space, the ridiculous problems I've had and how I've dealt with them. So I have kind of been working towards what will eventually be some sort of essay or paper of an idea of transformalist games. And what I mean by that is I'm really interested in looking at games that are more open as systems and allow for people to kind of create and experience agency. So I'm going to tell you the story about how I got there, because I think it's kind of interesting, and it's a kind of weird, non-linear story. So I had a band called Black Swan, and I've always had two loves, and one's making music, and the other one is making video games. And Black Swan was a really fun project. It was my attempt to merge these two things for the very first time. And what I was doing was putting sensors all over myself, and my friend had them on her cello bow. And we were attempting to use the data from our performance to actually help us create the music and move around a sort of musical space we had created. So we laid out a world in Unity, which is a game engine. And I had some very basic procedural animations that would play based on the sensor data that would come in from our various sensors. And eventually we upscaled to using the Microsoft Kinect when it first came out. And it was a really interesting and fun way to make music. And it allowed me to do a collaboration with a woman named Rebecca Feebrink, who is at that point doing her PhD and working on a project called Wekinator. And we did something that was really unique at the time. We used machine learning to train our sensor data. So gestures and movement could be transcoded into things like behavior. So I have a nice manifesto, and I kind of use this as a guiding principle when I was making the interface for my music creation tool. And that was that the user should never be forced to conform their body to the affordances of an interface. So if you think about performing music, the thing that drives me the most insane when I go to see an electronic act is when they're hunched over a laptop, right? This is just like not a natural way to make music or perform music to an audience. So I asked myself, what would be a kind of very natural expression and interaction, and how could I perform music in a way that was a little bit more like dance, but also gave me a lot more free control with how I interacted with the crowd. So for those of you who don't understand what machine learning is or what a neural network is, I'll give you a quick crash course. So this is a slide of Rebecca's she made for one of her talks, and she's got three different distinct gestures. One is holding up one finger, one is holding her hand like this, and another is holding her hand like this. So she uses a camera to record each one of those gestures and then feeds it into a neural network and trains the neural network. And then when the computer sees one of these discrete states, it can create an output with it. So maybe this is play track 1, this is maybe stop the music, and this is maybe bring the volume down to half. right? So that would give you this really rich interactive space. But what I actually really love is not discrete classifiers, but the ability to kind of use the interstitial data. So you can, instead of having a kind of 1 and 2, you can say, how close am I between 1 and 2? And you can get a gradient of data, which means you can be like, if this is the volume at full and this is the volume at half, that's going to be the volume like at 3/4, right? So it lets you build this really rich, really organic control space really quickly. So this is kind of like what a neural network looks like. If you have sort of incoming data, like a lightly bowed cello, and your arm is raised, so maybe if I'm raising my arm and my bandmate's lightly bowing, what we want to have happen is kind of the volume of the sound to change when my arm is up, and she wanted to have the ability of the graphics colors to change as she bowed. And you can train that kind of data, but then you get all that nice build-up data. So if you have like 50 of these different behaviors, you can get this really organic, kind of almost improvisational control space for your performance, where you don't actually remember all the 50 things you trained anymore, but you kind of get this really nice thing where you know that you've trained enough of your body moving that it will give you something when you move around. And this goes into something that I really encourage people to think about, which is kind of having interfaces that have play and thinking about designing and building interfaces which are open and allow for spontaneity. Does anyone recognize this tool? Raise your hand if you know what tool this is. You. Old internet users from the 90s, raise your hand, same group of people. This is an application called Auto Illustrator. It's one of the very first applications I ever saw that had procedural generated algorithms for the purpose of artistic creation. It was wonderful, and it worked a lot like Illustrator. It just made crazy paths. But it had things like suck my pixel and parody and multi-user and instant mutant design and generate and degenerate. And these kind of open parameters really had this very organic control space. So you sort of got some really interesting results just by sort of exploring and playing around with these generative algorithms. So after Black Swan, I started working on a project called Nightmare Kitty. Nightmare Kitty was an attempt for me to think a little bit more about how to put a user interface into the body. And it is not a music-making tool, as many of my games are, but it is an attempt to help children deal with fear. So they're this lovely little terrified mouse, and there are these evil cats falling from above. And I was really interested in having these kids experience a sense of helplessness, so I had them kind of always in this kind of crouched position to avoid these cats. But when the cats got down on the ground, the kids could sit on them and pop the kitties, which was actually really satisfying. They'd explode in a blood spat. And then the kids would stand up really quickly, and then they'd feel really good. So it's this sense of fear that you could overcome. So I really tried to embody the argument in the physical form. I wanted to empower kids in a way that had them going from this position to a more empowered body position over and over and over. That kid over there, this kid was like my best player. He was really ridiculous. But emotions, as it turns out, can actually be triggered in a response to an ecology or in a response to a game system. And all of this is based on this idea that has been kind of debunked in science, but then there's some alternate research that shows it might actually be accurate, called power posing. Some of you have probably heard about it. But it actually, the way we move our body actually causes neurochemical changes in our brain. So that's kind of a fantastic thing to play with. So the next thing I made was Night Games, which was another distributed musical environment, but instead of me playing it, I gave the controllers to children, which any musician in this room should do. You should take your musical composition, you could distribute it into an environment, and you could just hand it off and let kids play it, which is actually really fun. And part of me really wanted children to hear the way that they impacted each other. So I made a lot of the instruments kind of codependent on each other. So if one person was doing one thing with one, something else could trigger on another controller. So it looked like this. I got really lucky. A drum corps came and played it one night. So I have a little bit of video of that, so I'll play it so you can hear it. So I don't know why the video dropped out, but that's fine. So no idea. It's okay. I think it just dropped off because of the, that's life. But anyway, it's that amazing woman shaking those in a rhythmic movement. So yeah, it was really fun because you could easily hear when she's shaking them that it was triggering all the sound and the people around her. There's a couple of people in the shot as the video plays. But this allowed me to kind of think about games as ecologies. So I was like, actually I think this jumped a few slides. Okay, yeah. So I began to think about games as ecologies, like games as worlds we could build that could be open-ended and interdependent, versus games as economies. So often when we play video games, there are these really tightly tuned systems of economy. Doing something equals a reward, right? And you've got a goal. And I think this is actually really not so healthy a way of thinking. I kind of like things that don't have goals and maybe things that don't need specific rules. And I really was interested in how games could be a possibility space, and the rules are created by the play in response to the world. So in night games, the children would invent their own rules, and I saw similar rule sets emerge multiple times through multiple plays, but it was interesting to see how they would evolve them. And I didn't have to do much in response except for set the situation up in a way that favored certain rules. And an ecological approach to play where systems can kind of learn to adapt to the user interaction. And this is something I want to build that I've not built yet. I'm really interested in creating a unsupervised machine learning based game where the system itself is already learning from the players. And I really want to allow the players to evolve the rules as the play experience unfolds. And I think that this will create an empowered, agency-driven environment, and that's something we don't experience enough. So from there, I decided to take a crack at actually building something physical in the world. This is the very first thing I built. I called it Night Games, but it really kind of wasn't. It was a geodesic dome where 11 of these pads, actually 12, were individual sound triggers. And then the clouds would respond to your voice, and the tree would respond when touched. And there was a rock. And it would light up at night. So that's what I want to do. So I broke the control space, and this got moved. But and I had rocks, and then it was the trees and the hut and the stars, and then the clouds ended up on the very end. So this is what the clouds looked like. I designed them, and then I printed them out, cut them up. And my friend Adele Lennon and I worked on this game together, and we built the actual physical version of these clouds, which was quite large. This is the dome. A team of people helped us. That's what the inside of the hut looked like. And you can see, like, a good number of people could go inside and play it together. This is the rock. And I 3D printed the rock, and I embedded all the electronics. And this is a trick I want to tell artists about because it's really clever. And a friend of mine suggested it to me. I didn't come up with it on my own. But these little modeled holes are for earth magnets. So if you put one set of earth magnets on one side of an enclosure and another set of earth magnets on another, you can create a really tightly snapped 3D object. It's really hard to get apart, actually. And then I embedded all the electronics into here with a battery. So the rocks looked like that when they were done, and I made them glow in the dark because why not? And then, that's what they look like with the LEDs inside of them when you would, trigger different states. And then, you got to make the trees like geodesic, right? Paint them. I'm watching the history of Atari on the computer, cats sleeping, painting. I decided to put control boxes together because I figured if I was going to let people out in my world, I would make the systems really enclosed. That's Adele and one of our friends who was helping out. He was great. And it looked like this when I was done. So we got really tight to the actual model. The tree looked like this. Now, I want to talk a little bit about this because who here has heard about all the conductive paint stuff and kind of, I'm going to try that. Who's been disappointed by the conductive paint? Oh, yeah, I've been disappointed by the conductive paint. So the worst thing about the conductive paint is it's disappointing, but the second worst thing is sometimes people won't tell you where you're going to be playing or putting your piece. It does not look like this was designed to be outside, right? It's under a tent, which should be a tipper. They moved us outside at the very last minute. I had sensors on wood that was unfinished. They basically just sunk down into the wood when the wood got wet and my sensors quit working. I found a dirty hack by just taking the microcontroller, taping it on the side of the tree, and running wires directly to the pad. This worked. It was a nasty hack. I managed to have an installation in the end, but it was very difficult. That's the inside of the sensor with someone playing it. So some of the lessons I learned about this that I wanted to share with folks is resistance of wire really freaking matters. So I didn't really calculate the resistance of the wire around that giant geodesic dome. That caused some problems. Conductive paint and scale is an issue, especially if it's moist. So if you get put outside, your entire installation can break. You can't clarify your needs often or loudly enough to an organizer or from an organizer. We went back and forth. I swear to God, we were on the same page until I got there. Okay, so the next thing I worked on was BabyBot. Okay, hackers in the room, take note. These are amazing. These are heat shrink with solder inside. Think about that for a minute. You can put one set of wires in here, one set of wires in there, and melt it down. So you get your joint heat shrunk and soldered simultaneously, which is fantastic. They're worth the money. So this is the first time I decided to build a distributed musical environment using hardware. So who can think of a distributed, well, not distributed, kind of distributed, or an interchangeable musical environment that exists and has been played since the 60s? Anybody? Right? Modular synthesizers, right? You can kind of patch any set of modular synthesizers together if they're using control voltage and they'll kind of work. So these are two modular synthesizer units patched together with control voltage. So this is a step sequencer and that's a synthesizer on the top. And my idea was to have a way to patch together a ton of these and let kids learn about making music while also kind of getting a sense of their interconnection. So this is this. It was installed in the Netherlands in one of the big music festivals that I forget the name of. But I'm going to talk about this knob right here. This is the clock on the step sequencer. The inside of this thing is locked down. Every knob is glued. There are bolts. There is redundancy on redundancy. I had a child turn that clock knob so hard, they broke the knob. So, glue is not enough. Screws and bolts are not enough. And children are insane monsters which are capable of intense creative destruction. Limit the parts and make the interaction simple. One of the things I also learned is children don't understand knobs. Think about that. Think about what that means with smartphones. Okay, so then I wanted to make this for a show I did at Somerset House, so I made a game called Bot Party, which would be a lot more of these modular synthesizers. So I modeled them with a laser cutter on a dirty prototype, and I decided that having a bunch of cables with children would probably be a bad plan after I watched how they behaved with a bot that was locked down. So I thought, well, what's a way that you can get people to really get a sense of interconnection? And I was like, why am I using technology? Just have them hold hands. So now I use the people between the bots as a sense of trigger. So this is what they look like when I gave them faces. And then I put them in an installation. And the cool thing is the aluminum sides I CNC'd. And when you pick them up, they react. But then when you shake them, when you move them, they react a little bit. But when you touch another person, you unlock animals, And when everybody holds hands in a circle, you build a storm. So it's kind of a fun environment. You can see a bunch of people up there interlinked. So they have the storm, and then it's really cool because when some person breaks the contact, the storm stops, which is kind of fun. So that's kind of what they look like. So one thing I learned about this is that my cases needed to be a single unified piece. What is the first thing you think a kid did? Notice the faces. This was day 1. By the end of day 1, I had the glasses pulled off 2 of them. They pulled the faces off. So the cases must all be a single unified piece. Children will shake loose hot glued circuit boards on acrylic, screw everything down internally, super glue all the things always. I super glued the faces down after day 1 instead of using solvent to melt the acrylic. It actually worked. This is my next game. It's called Thrum. It's inspired by bees, and it's an attempt to get people to try and find a food source using a waggle pattern, which is the waggle dance bees use to tell each other where honey sources are. So it's, bees can communicate via vibration. So this is a vibration-based grid, so it's a haptic grid. There is a motor in each one of these little cells, and the idea was to see if people could do this. So I evolved. This time I was like, okay, I'm going to make a circuit board, less wires, right? Make things safe. And this is what Thrum looked like when I first play tested it. I'm making it with Heather Kelly, who's up there in the corner, and you can see people kind of filling around on the surfaces. It looks like this in final form, close to final form. So I'm pretty happy with the aesthetics of it. You'll notice that there's only one wire. I am down to one wire, and I figured out how to get rid of it. I'm pretty sure that if I put it in some place like the Science Museum, I will have to screw these pieces to the floor. I could see a child picking them up, looking for the bee beneath them. Kids are crazy like this. So this kid looks adorable. Don't trust the cute. So next up, all wires must go. I think that's something I've learned. The install must include a way to make the wires secure and dock the electronics into a lockable system. So that's what the bottom of Thrum is, where all the cables are. So you can look in the way that I routed. So all the wires run through the center. Okay, so I think I'm close to the end, but other problems. So timing is a real problem. So if you're dealing with Arduinos, you'll run into timer issues. Those can be a problem. Portability is also a problem. Clear writers. Everyone, just be real. If you work with an arts institution or organization, just be really clear about this. Funding is also a potential challenge for these kinds of projects. So anyway, I'm at Phoenix Fair. I'm sure I'm at time. So, yes! So the other thing I was going to say really quickly before I do questions is recently I've been reading this book called Embodied, and I hope you guys all go read it, because it talks about all the things that we can do with our bodies that are yet researched, and I want artists working with this stuff. So anyway, go buy that book. Okay, go ahead, questions?
First applause.
All right, questions?
Who has questions for Phoenix? Anyone? I have a question.
Sure.
So the last thing you were noting about the challenge was the funding. So I'm curious, like, how do you sustain your practice? In which context can this kind of work live?
I think it works really well in the institutional context. I would love to find a way to get my games to consumers. But I think these bespoke hardware games really struggle. A really good example of a hardware game that has made it to consumer is Fabulous Beasts. Have you guys seen this game? It's a NFC game. So it's a balance game, and there's NFC tags in all of the pieces, and you kind of stack them up like Jenga, and you play it on an iPad. So I was kind of impressed with how they were able to distribute that. So I think hardware games, there's a big question of how do we make something for consumers and how do we distribute it and how do we sell it. I'm watching a bunch of really talented indie games devs who build physical hardware games be really just stumped. And that's actually part of my PhD research. It's how we can figure out how to get these games to consumers, because institutions can only support this work to a certain degree.
Any other questions? I'm coming.
Just a quick one about the book, Embodied.
Oh, it's so good.
Who's the author? I can't find it.
Kristen Jamison. He's at Oxford. He's like a whoops, that's the table. He's a computational researcher. Sorry, not a computational. He's a cognitive psychologist researcher. I think I have his name wrong. Eggleston. Thank you. Yeah, no, it is fantastic. One of the things I've learned about it is that really crazy high performance dancers perform their ballet dances sometimes blind, and they'll practice dancing blind. So I have like a 20-year-old movement practice. So I tried to do yoga blind. I've never been so nauseous in my entire life. And it turns out our sense of balance is tightly tied to our visual sense. So imagine all the things you can do with VR in that, right? So go think about that. Go make things with that.
Yes, okay. Thank you, Phoenix.
Awesome.